So we need some rules to break down our big complex shape into small, understandable pieces. So rule number 1, anytime you see a pair of lines that cross in an X shape, what you're going to form are called vertical angles. Vertical angles are always going to be across from one another. So for example, this angle right here, which if I measured it with the protractor may be 30 degrees, the one that's directly across from it, formed by the same two lines, just across, is always, without measuring, exactly the same degree. That's a guaranteed 100% fact, and those two things are called vertical angles. The second rule we have that you can use to break down big, complex shapes into smaller parts would be when you have two lines that cross, very similar to what we just had with rule number 1, but this time the second line, this one, may or may not continue beyond. Sometimes it will, sometimes it won't. But either way, what forms are two angles that are not the same, as you can see. This angle is, in this case, obtuse, and this angle is acute, meaning smaller than 90 degrees, and these two angles are called supplementary. They're called supplementary angles. What's interesting about supplementary angles is if you know one of them, let's say that, again, if we were to measure this angle and it came out to be 110 degrees, then to find the second angle I do not have to measure. All I need to do is take the total degrees of a straight angle, being 180, and subtract away the part that I'm already aware of. I'm aware that I have a 110 degree angle, so I find that this missing piece has to be 70 degrees. The total of my two supplementary angles, when added, always must equal 180 degrees. So fact number 2, supplementary angles. To try and make a complex shape simple, we have a third setup here. You'll notice that you have 3 different lines. 2 of them come together at a right angle. When you see 2 lines come together at a right angle, automatically you can label, if you need to, that entire angle, the whole thing, is 90 degrees. But you'll notice in this particular image, we have an extra piece coming out from the center, or from what we'll call the vertex, splitting this 90 degree angle into 2 smaller pieces. Those 2 smaller pieces, or those 2 smaller angles, this angle here and this angle here, are called complementary angles. And what's important to know about complementary angles as rule number 3 is this. If you know one of them, let's say this one right here is 20 degrees, for example. If you know one of them, then much like you did for supplementary, we take the total number of degrees, subtract away the one that you know, and what remains ends up being the other angle. So you have 3 rules so far. You have vertical, supplementary, and you have this third one called complementary. Use those to try to help you find some of those complex missing angles. Rule number 4, when we're looking at a complex shape and trying to make it simple, involves parallel lines. Now, parallel lines you've learned about in the past. They're lines that are in the same plane, they are equally distanced apart, and they never converge, they never touch. What you'll notice in my drawings, you'll see double arrows to show that the 2 lines marked with double arrows will be parallel. Now, I have this thing that cuts through them, this line called a transversal. You're going to hear that word a lot, and transversals develop a lot of different angles for us. The first example I'm going to use, which will end up being rule number 4, is going to deal with this thing called alternate interior angles. Now, alternating means going one and going the other. So alternate interior angles mean on either side, inside, and they are angles. So when I'm looking at alternate interior angles, they would be like these. Here's my set of parallel lines, here's my transversal, and I'm on the interior. So this angle right here, for example, is the same angle, if this were x, as on the alternating side of the transversal, but still interior of the parallel sides, this would also be x. If I were to mark them a different way, this angle in yellow would be a different angle. This would be 180 minus x, you know from rule number 2. This angle up here then would also be 180 minus x. That's how you find all interior angles in a right triangle. Rule number 5, you'll notice the drawing is exactly the same. We get a little bit of a different thing out of this. Over here, these are called alternate, I'm going to abbreviate that, exterior angles. They are still formed when you have a pair of parallel lines, when you have a transversal cutting through them, and then what you'll find is the only thing that's changed is the word interior has changed to exterior. So the idea is the same. They're still formed along the line here called the transversal, but in this case, if I called this angle, for example, notice how that angle is on the outside or exterior of the parallels. And if that were x, guessed it, down here, this one would be the same degree. Those are alternating sides of the transversal, and they are exterior of the parallels. Likewise, back to rule number 2, the other set of alternate exteriors. 180 degrees minus x would be the remainder there for yellow, and over here, alternate side, exterior, would be the other angle. So that's rule number 5 and number 4. Rule number 6 looks a whole lot like the beginning of rule number 4 and 5 with the same sort of drawing. But rule number 6, you'll find, does not relate to alternating sides of the transversal. In fact, rule number 4 and 5 both related to one side of the transversal, the alternate side. Rule number 6 is all about the same side of the transversal. Corresponding angles when dealt with involving parallel lines look like this. This angle right here, we call it x. If I imagine this symbol and I simply shift up, this is the same. That is also x, automatically. Likewise, the interior angle here, if I call that, notice that using rule number 2 again, that would be 180 minus x. Its corresponding angle. Now I'm not going to clutter up the drawing with the other side, but you can imagine that the other side would have the same thing. This would be a pink x as well, and its corresponding side would be this one. I'm sorry, corresponding angle would be this one. And this yellow would end up over here, and its corresponding. So that's rule number 6, and out of our 7 rules. Rule number 7 is a rule that relates triangles to these complex shapes we're working with. Something that's important to note. When I have a complex shape, or if I were to have a very simple shape like a triangle, the triangle has 3 angles, just like it has 3 sides. And the grand total of the 3 angles is always going to be 180 degrees. That, in essence, is rule number 7. Now what that does for me is this. In this I see 1, 2, 3 triangles. I also see a 4th triangle right here, and I see a 5th triangle that comes up and over and down. So there are lots of triangles in this shape. If I were to give myself some measurements, let's say this one were 20 degrees, and this one were different at, let's say, 30 degrees. To find a missing angle x, I would simply take 20 degrees, the 30 degrees, and add them together and get 50. And then subtract that from the total that we have here. When I subtract that, in this case, I'm going to have x becomes 130 degrees. That, in conjunction with the other 6 rules, will give you everything you need to take a complex shape and break it down and make it simple.